Hello and welcome to Section 8, Part 2, where we're going to have a look at the command pattern initially before we start coding. The command pattern is conveniently named exactly what we want to implement, although the command pattern can be used it is used for other things other than issuing commands. You've probably used it many times before in software and not even realized. The main purpose of the command pattern is to take a request, transform it into a standalone object that contains all the information needed for that request. So encapsulating that request into what will be for us, it will be a command class, and then that then allows us to store that command, pass it around, delay it, queue it, undo it, redo it, have a command history and whatnot. So the command pattern itself consists of four main things. So there's a command interface and there's a concrete command. So the concrete command is what has the implementation details of what the command does. So there'll be a base class that sort of sets up what every command should have, and then there'll be an implementation of the command type which has the exact execution data for whatever this does. And that interface will then, and then the other two things are an invoker and a receiver. So the invoker for us will be our player or player controller, which will then, the invoker is what holds the commands and manages the queue and initiates the command, so like processes the queue. But when we click or we do whatever to create a command, issue an order, the player or the invoker, is what will gather the data. It'll push that data through the command interface, which is basically just a class that we have a generic way of passing data to, and then that's our command created, and it sits in the queue in the player until it's processed. And then, and they're all saved in a generic format, which is that concrete command. So when it comes time to execute it, the invoker, i.e. the player controller, doesn't care what's in the queue. Like it just, the individual, whichever implementation of command is in the queue, it doesn't matter. It'll only read the command to the extent that it needs to know, can I execute it right now? And then it'll just say, okay, command, you're good to go, execute. And that's where we get that decoupling from the command, from the invoker to the receiver. There's not a solid link here that says every command has to do this. So each command will have its own execute function and it will tell it what it needs to do when it executes. So for the purpose of our navigation command, it's going to execute and it's going to say you've got player selections here, whatever the player is selected, and we want to issue this command, this navigate command to the groups, and it's going to get passed to the groups, and the groups will handle, okay, these are my entities that are selected, I'm going to move them. That's how it's going to work. So everything the command type needs to execute will be in here. So it'll have the implementation for execute, undo, redo, and so if the command queue is doing like from the command history, say it's doing an undo command, then it's the same story as execute. It'll have that implementation of what to do with the data that's in that command to perform that execution or undo or redo. And when the command finally gets to the receiver, aka the entity, then all we have to do is format our systems to accept a command, and we can accept multiple commands in the same format, and we do not need to worry about. So this first system is, say, our navigation's set up, then it knows it can just take a command and it knows it to pull out some data so it can generate its navigation data and perform its navigation. Now, we might have some other command here that's for a building or something, and it'll come through and execute, and it can go straight to it doesn't have to go through the group like this. So this command can come from the same queue, but go to the building and execute something else. So the main intent of using the command system for us is so we can issue those commands to entities and have a queue for those commands and a command history. And that command history then allows us to have undo and redo commands, which I'm yet to implement, by the way. So the functionality will be there. I just haven't fully fleshed out like an undo or anything like that yet. So that's the command pattern, roughly, very roughly, enough for us to do our command system. So we're going to start coding now. Let's get into it. So to get started, we're going to come into RTS entities under public framework, and we're going to create go into, we'll just create it all in, we won't create a separate class for the data, but we need to create the data first. We're not going to get very far creating classes without the data, since the classes are kind of the data. So like if you think about a command, it's basically just data. And there is two ways you can do this. You can either create, I'm going to create structs and use those structs on the command class, where theoretically a struct could be a command, but you could also just have all the properties on the command and issue all the data into there. Yeah, there's a couple of different ways you can do this, but this is how I'm going to do it. I like structs, but I still want to use the class system for the commands. So I'm just going to come down to the bottom and create our first struct. So the first thing we're going to want in our data is a ID for the command. So there's going to be instances where we don't have to pass any data. We just want to do a lookup, such as talking back to the command queue. We can say, hey, I'm looking for this command ID. This is now complete, or this has failed, or whatever. So we can just use fgood for that. We're going to need a command type. So what I might do, I'm going to put a big thing in here so we can find this in this huge bloody data types thing, because we're going to need some enums as well. We'll just keep it all together. Could put this in a different file, but we're going to need the classes above referenced down here, like our selections and stuff. So we might as well just keep it in here anyway. What do I do there? There we go. So this one's going to be our command type. And this will just be an easy way to reference what type of command it is, rather than doing, you could do just a is a function on the class, but this will help us look it up when we want to create from the class. I'm going to have, I don't really have no command, but let's call it idle. I don't, just something that's not a command type, and then navigate to is what we're going to create. And this will grow as you add more commands, right? But this is, oh, hang on, we need a class here. And the next one is, so some commands are going to go into the command queue and others won't. So this will just be a variable to say, hey, is this command queued or not? And a good example of that is, so if you hold, say, a key to queue up commands, like I was holding control in the demo, if I just issue a command without holding control, then I want to override all those commands in the command queue and just issue this command straight away. So this is what will allow it to do that. It's basically just a bool. Now I'm giving all these U properties. I'm not giving it blueprint interfaces or anything. So I'll probably make it a blueprint type actually, but it doesn't really need to be honest. If you want to look at it or use it in blueprints, you'll need to add the blueprint type and then add all the blueprint excesses, like edit anywhere or whatever for the blueprints. So now I'm going to use transform for, so rather than just pass a vector for the position, which is like the destination or whatever, I'm going to use transform so I can include the rotation. Don't really need scale, but I can call this target transform. Later when we go to do undo features and stuff like that, you'll need to know the source data. So we want to have a source transform as well. Like where did this command come from? And it will help with navigation anyway, that we'll use it. Another thing we're going to need, and this is for determining who we're getting data off and reading stuff from in the group. We need just an int for the lead selection index. Some of these aren't going to make a lot of sense, but you will, it'll all come to fruition. So now we need our player selection. Player selections. Yeah, so this is where this is going to start differing here. So we need to create a new, we just copy this one. We can probably copy that constructor as well. Come underneath here. And we want to change this to player selections with an S. You can rename it to something else if that's confusing. But basically this will be multiple selections. rather than having just an array. So in here, we'll have, rather than just group, it'll be an array of player selections. And the reason why we're making it a struct is because we want these other properties. So we want the int 32, we want the lead selection index. So this is the index of the group that is the leader of the multi-group selection. Gonna get crazy, I told you. We're gonna need some more data for the formation data and stuff like that, but I'll just placeholder this for now, because we just don't want to get too crazy on the formation data, on the data implementation yet, otherwise we'll get lost. And then we just want to use a valid check for this. And I might actually do an implementation for this rather than inline. And I do it inline anyway. Do we not have, I thought we created that. So I'm just going to come to private framework data. No, we don't have a CPP for our data type, so we're going to create that. It must have been core that we did that for in the multiplayer videos. I'm just going to go add file. Just copying this out of here, easier. And so in our invalid check, we want to return the selections is greater than 0, and our lead selection index is valid. And then also we want to, so if we do have selections and we have a lead selection index, we want to check that the actual lead selection index is a valid selection index. Also, check that if that is a valid selection, so lead selection index, we want to check if that group in that selection is valid. So we're definitely making sure we've got a valid, because that's where we're going to pull all the data from, like to do stuff, is that lead selection, like I was saying. It grabs the formation data and whatever else from the lead. So that's how we can fix these up now. So this will be selections. And just, so we don't need that, just need that. And I'm going to make another function here for clearing it. So and we'll get another one that's going to return our group. And this is going to be the get lead group. So we const, and we'll implement that in the CPP. And we just want to check is valid. So that determines that that the group is not null, the what's there above. Oh, I forgot the comma there, semicolon. So yeah, we know we've got a valid lead selection index and a valid group and all that, so we can just return this. All right, that'll do for that for now, because it's gonna, the rest of the functionality is gonna be based on this formation position, which we'll come back to. I might actually put in the selection. And we don't need that second constructor. Okay, so now we can grab this player selections and add that to our, and we're going to call this selected. We don't really need this for navigation, but this would be good for when you're targeting something with a command. So whatever you hit with the mouse or whatever, when you click, this would just, if you want to do like a follow command, this would be probably good too. Like you could have the target actor there. And now we just need a bool, or I'm using an int 8 here, but just that has navigation. So this is to say that this command that we're implementing has actual navigation with it, so it can allow us to have navigation in different commands other than navigate to. This one I might just implement later as well. This will be the navigation. We'll have a struct that is the navigation that we're passing along to the command, and then that should do. And then we're gonna do this up here. Just implement some defaults now. So I'm just going to put this in line so it's a bit easier to read. Now to make an invalid GUID, you can just create it like that, and that will create a 000 GUID. Whereas if you do, to make a valid GUID, you have to do create GUID, is it new GUID? And that will give you a valid GUID. So that's a good way just to create something that's readable but it's not actually a valid GUID. So we can actually check that later, like is id.valid, and that's checking if it's a legit. We'll actually use that functionality later. Yeah, I'm just gonna default to idle. Should queue, no. What was the next one? Should queue target. Actually, there's probably one other one we need. Yeah, I might add that in before I forget. Put it in here, should queue, and we'll put in a status, which will be another enum. So in here, we're going to have no status. It's going to be queued, be active, aborted, updating, completed, or the command can be a preview. Right, so grab that. In here, no spot status. I might do that with that as well. Doesn't need to be command type, just type. Yep. So, yep, and this one, so this will now be status. That'll be no status. Then we've got our target transform, and we can just make a blank transform for that. Our next lead selection index, move one, our selected. So we're just going to create a new player selections. So it'll be a blank generic, basically an invalid one. Alright, so I'll just tidy that up. Now, one other thing we're going to need is we're going to need another. So because a command comes from the client, we're going to just want to gather some data on the client side and send it to the server to then create the command, which would then create this. So we're just going to create another struct, which we're just going to call the, we'll just call it client command data. And we'll just use this because structs are a good way to get data to the server through RPC. So that's what we're going to use this for. So this will have the command type, so we can copy some of these. Because it's essentially going to be feeding into this. We're going to have as navigation, and then it's the target and source transforms. That's good. So like the target is the mouse click, so that's the data on the client side. So we're just going to use that. What we'll do is we'll create a default constructor and a second one so we can just populate it with a constructor. So let's just copy these. And then if we make another constructor, we can then pass in command type and pass in I think that's all we'll do. So by default, if we can pass in a type and if it has navigation or not, and then by default, the target and the source will be blank because we'll need to generate that. Let's implement some functions for this as well. That's just a quick way to, sorry, let's just type it. So that's just a quick way to check that it's not used, it hasn't been created with this constructor, it's been created with this one. And then we're going to create setters for the actual data on the for the transforms. We're going to want to set a target location rotation and a source for both as well. So because this will create an actual transform. It'll just have 0, 0, 0 as all the numbers, and then so this makes it valid to be able to set data into it then. No, let's put that in the wrong one. This one goes here. And actual rotation on a transform is a quaternion, so we can just transform that like that. There we go, that's our client data. Now, I think I've getting an error here, so I think I've missed a bracket or something. Oh, just didn't run that out. There we go. So I think the next data we'll create is that formation position. So I'll just create it above, we'll create it at the top here, so because we're going to use it below. And this is going to have a few settings, so this will sort of what will feed into our navigation later. I need a enum for this one, so let's put it here. And this is going to be for the selection side. And this is for the formation position, whether they're left or right or in the center. We're going to need a so which entity this position belongs to. And we're going to need their player selection. Means I'm going to need to move some stuff around because that's above player selection. So I'm just going to grab this, put it in between these two, because this has to go into the selections here, but I need a reference to selection. Oh, there's going to be another struct. Alright, just leave that one for a second. This one's just an array of vectors, so I'll just do... And then we need a bool for whether to use a formation or not. So later when we implement should I wait for this guy because he's not in his formation position? This will come in handy. And also, I do a thing where if the units in the group are all scattered around all over the place, rather than like send them to their start points for the formation movement, I actually set the form up point half, like a bit down the navigation path, so they'll sort of, it gives it a more fluid move, so they sort of move towards forming up into a formation. So this flag, and then you got other things like if the movement is like 20 meters, then you don't want to form up into a formation. So that's what this flag is, passing it along basically. I think that's it actually. And then what we'll do is do another is valid, and this will just be the only real way we've got to check if this is valid is if the destination is like not 000, or the selection has no side is another one. No, I don't want to do is valid on the owner because we won't have an owner initially and we still want to use it. So if we just do not, sorry, is nearly 0, that's what we want. And we'll just do side not equal to, I forgot the return. Alright, so we need to do some default values here. What am I doing? Copying the wrong thing. And this is 0 rotator. There we go, it's our defaults. What are we missing? Are we missing one? Oh, use formation, I missed. Oh, there's more here. I'll put this in as well. And we might create this struct now, so another whole. And this one is, it's similar, like it's the same sort of thing, but one's for a group and one's for an entity. So it's going to be entity position, kind of like the entity position in the group formation position, I guess. So we can probably copy some stuff out of here. Copy destination. We can copy owner. I'll put owner at the top. And then rotation as well. I'm just going to copy destination in again because there'll be a destination for the entity and there'll be a destination for the formation. Start. It's just later on when we're doing navigation, it's much easier just to be able to pass this around and get the actual entity data and what we need for that calculation. We can pass in the side. And then the last couple will just be float for spacing. And this is what I was sort of talking about before. So we just need a number for, this will be we're going to have waypoints. So like it'll be at what waypoint do we start using formation. So it's going to, I'm just calling it form up index, or whatever really. So that's there. And then we need a constructor. Owner. Oops. Rotation. And then for both these, we'll create, actually I'll do is valid check as well. And for this one, we will just use owner. For the return again. And then we're going to create constructors, these, so we can just pass in params on construction. So let's just bring this down as well. I think that'll do for the constructor. Might rename that, it's a bit confusing. There's a location, but there we go. And the reason why we're not just passing in all attributes is because some are for the creation and some are for just updating later as we use it. Like it'll be used as a place to store the data. So we need to do a constructor for this one as well. It's kind of similar to this one, so copy that. And then this one will be in offset. Inside. Right. The only one we have left to do is, oh sorry, we can now in our formation position, we can now put in an array of entity positions. And we can grab our formation position into our player selections, which will also be an array. You can see there we've got the individual entity positions, which are then stored in the group, or what do we call it, formation position. So formation position is like a group formation position, which has all the entity positions. And then we have multiple group selections, which has all the group formation positions for each group. Some crazy data. I think I might leave this here, and then in the next episode, we'll look at creating our formations. And that's, we need to feed that into this existing data, but also create the asset, go from there. Thanks for watching. See you in the next part.